we are going to review Chapter 11 quiz. As I pointed out, there are a couple of mistakes in the quiz, so everybody's going to do better off. I can't explain. I have not gone back and pulled up the questions, so I don't know if it was just typos or what. But quiz number 1 here says a recent study focused on the number of times men and women send Twitter messages in a day. The information is summarized as follows. At the 1% level of significance, so we know we've got alpha is 1, is there a difference in the mean number of times men and women send a Twitter message in a day? What is the value of the test statistic for this hypothesis test? Well, first off, I just want you to realize that it's basically asking if men and women are or not equal. So that would be the hypothesis test. It doesn't ask you for that. But here's something else that you need to pay attention to. Given that we know the population standard deviation, I don't have a lot of time to go through and reteach this, but I am going to go over quickly to the website where you have access to. And if you go through that, I'm going to click on page 1, you can see here that the very first example is talking about with the known population standard deviation, and it gives you this nice test statistic. Basically, it's the difference in the sample means divided by the pooled standard error. Error, E-R-R-O-R. So, we're going to use the test statistic, X1 bar of women minus X bar of men over the variance of women over the sample size of women plus the variance of men over the sample size of men. Okay? Just go back and take a look. You can see this is the formula that we're using. Men versus women divided by the square root of the variance of one divided by that sample size plus the variance of the other divided by that sample size. When you do this math, you're going to get 30 minus 20. I always put the larger one there so that we have a positive number. You just have to keep them straight. So 30 minutes versus 20 minutes is X1 bar minus X2 bar, or the average for women minus the average for men, if you will, divided by the square root, the variance of, now notice it gives you standard deviation, but the formula calls for variance. Okay? So that might be a mistake that was being made. But as I said, this is the answer here that was given, and I don't get that answer when I work through it here, and I did it twice. But we've got a 10-minute standard deviation, but we need to square that because it calls for the variance, not the standard deviation, divided by the number of women, 30, plus 5-minute standard deviation squared, because we've got to use the variance, divided by the number of men, 25. When I do all of that math, I get 10 divided by the square root of 4.33, which equals 10 divided by 2.08, which gives me a z-score of 4.80. which was not one of the answers that was provided in the quiz. The quiz answer showed that this 2.4 was the right answer, but that is not. So this question is going to get thrown out. Everybody will get credit for it. But you do need to know how to do this. And you need to understand that the reason we used the formula we did was because we were given the population standard deviation and or the population variance. The next question, I can tell you here that this asked for a p-value, but all of the answers were not p-value questions. But I'm not going to ask you to do any p-value questions at all, but I will just say you should be able to have answered this question because we know that the z that we calculated was equal to 4.80, and if you were to look at a 1% level of significance, based on this pool sample, it would probably be 2.5 or something. I'm not going to take the time to go look it up, but you would be able to reject this null hypothesis. But once again, this question is going to get thrown out, and you do not need to know how to do p-values at all.
Someone said wait, and I'm asking what she means by that.
Okay, let me point out something. Danielle just said that somebody's asking a question. It is about 15-second delay, so if we have to go back, we can.
Okay, they're asking why is women first for the variance and population just because it is the mean, just because the mean is larger?
The reason that I put it first is because it's larger and I wanted to deal with a positive number. It wouldn't matter, because if you'll recall, the way that I've taught you to do this, you take the absolute value of the z that you calculate and you compare it to whether it's greater than, less than, or equal to. But if the absolute value of z is greater than whatever the book z is, and that's the critical z, but I'm going to just write the book z that you look up, then you reject HO. So the question doesn't matter which one goes first when you're comparing the means, as long as you're consistent. I chose women because it would give me a positive number to work with. Okay? So I hope that answers that.
And L. Blackwood said that's what I came up with, 4.8.
4.8?
Yes.
Okay. So Lori came up with 4.8. Did anybody else watching come up with 4.8? Just type it in and tell Danielle, but I believe that is the case. So, now, so far you've gotten 20 points. Everybody's gotten 20 points, and you're getting ready to get 30 points, I believe. This one also is a study between men and women and what they save. The information is summarized below. Assume the population standard deviations are equal. Okay? Now, it assumes they're equal, but it gives us a sample standard deviation. So we don't know the population standard deviation. So I'm going to tag over and show you which one you're going to need to use here. I'm going to go all the way to the bottom. I'm going to hit next. That's proportions. So you need to, while I'm here, you need to make sure you go through this material if you're not doing it. Oh, I would encourage you to. Now, here, two sample hypotheses with known population standard deviation unknown, but it assumes that they are equal. It assumes that they're equal. So now we're going to have to deal with a pooled variance. Okay, this is going to, now I want to read it. Do women save more than men? So here they seem to suggest that the mean woman saves more than the mean man. So we're going to write it this way. And once again, it doesn't ask you how to do the hypothesis, but if you just get yourself in the mindset of asking these questions, I think you'll do better. Here, our test statistic is going to be Z. X1, let's see, women is bigger, so I'm going to say X1, X women, X bar women minus X bar men, which is the difference between the two. And now we're going to have the pool variance, 1 over the sample size of women plus 1 over the sample size of men. It doesn't really matter whether you do 1 over 1 or 1 over the other first. Okay? Now, you're going to drop down and do the pool variance. The pool variance, it gives you that formula. I'm not going to spend a whole lot of time doing it here. This should be here, though. That should be SP squared there. Okay? The pooled variance is N1 minus 1 times the variance of sample 1. So we're going to say the variance of women times the sample size of women minus 1 plus the sample variance of men times the sample size of men minus 1 all over sample size of women plus the sample size of men, minus 2. Minus 2. And if you'll think about this, this is just basically degrees of freedom is n minus 1. So when you pull them, you've got n1 minus 1 plus n2 minus 1, which just gives you the sum of the samples minus 2. Now, when we do this, I'm going to 100 squared times 39 plus 80 squared times 49, which is n minus 1, divided by 50 plus 40 minus 2. 50 plus 40 minus 2 gives you 88. Now, when you calculate that number, you get a big number, 7995, I think it is, and when you take the square root of it, I get 89.4. When I come over here and continue working, the mean, I get 500 minus 475 divided by, well, the way I've written it here, I would use the 7995 number times 1 over 40 plus 1 over 50. I'm just making a mess of that. You've already seen that, so bear with me. You can always stop and go back if you need to re-see it. Over 1 over 40 plus 1 over 50. I get the z statistic to be 1.32, not 1.73. So what do I once again will ask out there, what all did you get? I really haven't gone by and compared who missed what, but there's 3 questions that there are mistakes on so far.
L. Blackwood would like to know, so the sample size is larger than 30, so we still use T?
Why use Z? Okay, Lori, you're calculating a T statistic or a Z statistic, either one. It shows here that it's a T statistic. And that's fine, whatever you calculate, whether you do a T or a Z, the formula's the same. When you look up your, when you look up your value, in this case, it's set at the 1% level. Well, if we used a Z statistic, it's a one tail, so what you would look up would be 0.49, and that 0.49 in a Z table would give you, let me see if I can quickly find my tables. Did I have them here? T table, yep, there's a T table. So, and also I'm going to go ahead and open the Z table. The Z table, the one that I just showed you, you would look up 0.49, and when you look up 0.49, you're going to get 2.33, I believe. That's it. 2.33 would be your Z statistic if it was a Z test. However, technically, Lori is right. It is a T test because we got 2 samples, and each sample was smaller than 30, not just the combined sample. But here, if we go to the T table, and we had 40 plus 50, so we had a combined sample of degrees of freedom of 88. So if you drop down to 88, let me see which one is going to be a one-tailed test. So I'm going to need to be in this column here. And I've got to find 88. Oh God, it's going to be all the way over here. 88, it's 2.36. So it's really, you're comparing 2.33 with a Z, and a T is 2.36. So there is a very small area there where you would have a different answer if you used a T versus a Z, but technically you should use a T statistic here. Okay, and so the T would be, let me go back.
And Brooke said I got a 1.286, but I used a different formula. I used the PC one.
The proportion, let me go back. That is not, you wouldn't use the portion,
Capital P, lowercase c.
yeah, I think, oh, let me see. I think here's what, is this what you're suggesting you used? If that's what you're suggesting you use, that would not be correct because this is proportions and we were not doing proportions here. We were talking about the average money, not a, so you're going to use a T or Z with, you're going to use mu when it is average money, average time, tweeting, average whatever. You're going to use P when it is a percentage. Okay? All right, and so once again, that is another error that, and I think that's all of them. But I do want you to understand what and why, because this will be on the exam. And if you have questions after going through this, let me know. Question 4. Question 4 says a study focused on the amount of money single men and single women. I guess this is the same question. It just wants us to calculate the T. Is it the same question? Oh, okay. What is the test statistic? It wanted, here we were calculating it. Here we're just going to look it up. It's asking you what is the critical value. That means what is the book value. Okay? First off, and as in the previous one, I set this up for you so that you would know if it were a one or two-tailed test. You can see because it's got less than and greater than involved, it's a one-tailed test. So with a one-tailed test, you're going to have the rejection region, whatever it is, and here it's 1%. So we're going to look up 0.49. But as per Lori's question earlier, this is a t-test, and it's going to have degrees of freedom of N1. And that's an interesting question, Lori. You've already solved this problem from your previous question. You're going to have 88 degrees of freedom. So when we go and look up, this value, 88 degrees of freedom, at the 1%, we've got a level of significance, one-tailed test, 1%, you drop down, there's that 2.369, that is the answer, and that one was correct. I wish I could. So 2.369 would be the T at 0.01, 88 degrees of freedom, 2.369 would be the correct answer there. Looks like this continues on. At the 1% level of significance, okay, well, you've already got the answer. All you've got to do is solve it now. So we know we've already set this up. We did our pool T test, and we solved it back 2 questions ago to be 1.32. The calculated T is 1.32. The T at 1%, 88 degrees of freedom, is 2.369. Your decision rule would be if the absolute value of the calculated T is greater than the T in the book, which is here 0.01 and 88 degrees of freedom, is 1.32 greater than 2.369. No, so therefore you fail to reject the null hypothesis and conclude that men and women don't really save any differently. So you fail to reject the null, and therefore we cannot conclude that women save more than men. Okay? And that's going to be a reflection of the means are pretty close together, but the volatility of men is greater based on the sample standard deviation. So the answer is fail to reject or do not reject, depending on the way it was worded in your question. Now, Brooke, I think we might be proportion bound. In a market test of new chocolate coffee, a poll of 400, so I'm just going to write here, N1 equal 400, or I'm going to call ND for Dobbs Ferry is 400. Show 250 preferred it. So here you're really going to have the sample of Dobbs Ferry to be 250, or that should really be N, not. Let's do something different. Let's just call it the proportion in Dobbs was 250 over 400, which gives you, I don't know the number. But I didn't write it down because that's not really what they're looking to do. But the proportion in the other place was 170 over 350. Now, you can calculate what those proportions are, but the question is, to test the hypothesis that a higher proportion of Dobbs Ferry prefer the new coffee, what is the alternative hypothesis? So the hypothesis is going to be, if we're testing that the higher proportion of Dobbs Ferry, so I'm going to say Dobbs Ferry greater than Irvine. So this has to be Dobbs Ferry is less than or equal to Irvine. So that would be, your alternative hypothesis would be that. Pi of Dobbs Ferry is greater than pi of Irvine, or Irvington, or whatever it is. Now, the next question, it just says, suppose we have a test difference of two proportions at the 5% level. If the z statistic is 1.07, what is our decision? Well, if we're going to test the difference between two proportions, so it's going to be a two-tailed test. It doesn't say whether one is greater than the other. It says test the difference. You're going to have 2.5% on each tail, which means from a z, and remember, in a proportion, you always use z, okay? So when you go look up 0.475 in your table, you're going to see that the z 0.05 divided by 2 is going to be 1.96. Now, quickly I'll go over there and show you. 0.475, here it is. Oh, no, it's not. That's 0.475 is right there, 1.96. So 1.96 is the absolute value of negative 1.07 greater than 1.96? No. So we fail to reject the null hypothesis, whatever it is. We fail to reject the null hypothesis that that there is a difference in between the two. Whatever they might be, we fail to reject that null. Now, this one is going to take you, and what I would encourage you to do is what I did, is I used Excel. I used an Excel spreadsheet and calculated it, but let's just read through it. The net weights and sample of bottles filled by machine by Edna is so forth, and the other filled by a similar machine is so forth. Edna has 5, 8, 7, 6, 9, and 7 grams. Orno has 8, 10, 7, 11, 9, 12, 14, and 9 grams. Testing the claim at the 0.05 level that the mean weight of the bottles filled by Orno is greater than the mean weight of bottles filled by Edna. So now we know we've got a one-tailed test. So we're saying that the mean weight filled by Orno is greater. So O is greater than E, and O is less than or equal to E. What is the critical value? Assume the standard deviations for both. Okay, the critical value that they're asking for, now I'm gonna just show you the answer here, where we could do, the mean of E minus the mean of O, or actually that's mean of O minus the mean of E, because, O is larger, right? Over that's the formula you're going to use again. And when you go through, you're going to get 3 divided by 1.05, which I get it to, I get a final, no, that's not the answer. But the final answer is 3.83 for the t statistic that you're calculating. But it didn't ask you that. It wants to know what is the critical t value, assuming equal standard deviations for it. Okay, I've written down here 0.05 divided by 2, but I should not be dividing by 2 because of we've got a one-tailed test here. So let me see. We're doing this live, so let's see how that pans out. Let me use ET. So we had a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So N1 plus N2 is 14, minus 2 is 12. So we would have 12 degrees of freedom on a one-tailed test. Now, the one-tailed test at 14, still need to go up more. At 14 degrees of freedom, it's 1.761, and the answer is 1.782. Okay. Oh, nope. It's because I'm stupid. Here's 12 degrees of freedom, not 14 degrees of freedom. N is 14. N minus, the total N1 plus N2 minus 2 is 12 degrees of freedom. So here you go, the one-tailed test, 12 degrees of freedom. That answer is 1.782, which also was correct in the text.
L. Blackwood and Brooke both were wondering if they could use the TI-83 calculators for computing this because it helps in answering them the questions within the 30-minute timeline. You
mean, does it give them the critical value, that calculator? I'm assuming you're saying that it gives you the critical value, and that's fine. I mean, they can use anything that they have access to except cheating, okay, except someone else. Well, and also, let me point out, if you read the question, you didn't need to do any of this. You do need to realize that it is a one-tailed test in order to look up the right value. But looking up that t value should not take you very long once you are in the mood. Okay. Oh, did I skip one? What happened there? All right, number 9 says, using 2 samples, we test for a hypothesized difference between population means. Standard deviations are unknown, but assumed to be equal. The number of degrees of freedom in the first one is 15. Number in the second is 12. The number in the sample is 15. The second is 12. How many degrees of freedom? You need to just know N1 plus N2 minus 2, which is basically what you just did in the previous one. 25 degrees of freedom.
Brooke asked, so we can't use Excel during the final, right?
Yes.
Yes, you can.
Yes, you can use Excel.
You can use Excel.
Yes, you can use Excel. Now, you cannot come in with pre-programmed spreadsheets to use during the final, and I don't even know how you would do that. I mean, if you had something to calculate the sample mean and sample variances, I wouldn't have a problem with that because, but you're going to have to type it in. You're going to have to type in the data, so I don't know. You can use Excel to help in the formula, so that's not a problem at all for me. I mean, I want you to understand when and why you use them. It's not necessarily what you use to solve the problem.
There's another comment. L. Lockwood said, Dr. Waller, I answered number 4 incorrectly even though I had the right answer because of number 3. Can we get credit for that one as well?
I will consider those later. That's not a question to be asking during a session. Number 10, a national manufacturer of ball bearings is experimenting with 2 different processes for producing precision ball bearings. It is important that the diameters be as close as possible for an industry standard. The output of each is below with the average error in the industry is calculated, results are presented. So you've got a mean of 0.002 millimeters, a mean of 0.026 millimeters, and so forth. Sample sizes of 12 and 14 respectively. The researcher is interested in determining whether there is evidence that the 2 processes yield different average errors. Assuming the population standard deviations are equal, what is the critical value at 1%? This is actually, I drew a, that would be 0.005 if you were using a Z, but really you're going to look up a T and it's going to be 0.01 and it's going to be 26 minus 2, 24 degrees of freedom. So you've got first off, you need to tell me, is there evidence that the 2 processes yield different errors? Is it a 1 or 2 tail test? Nothing in this suggests anything other than they're equal or not equal. It doesn't suggest that one is greater than the other, so this is going to be a 2-tailed test. That's why when I started down here, I had done 0.005, 0.005. But you go to the T table, once again, 1%, 1 tail, 24 degrees of freedom, 1%, 2-tailed, what did I say, 24 degrees of freedom, there it is, 2.797. 2.797. So it is plus or minus 2.797. Why is it plus or minus? Because it's a 2-tailed test. You've got a rejection region to the right, which is positive, but the rejection region to the left over here would be a negative value. So you really have minus 2.797 and positive 2.797. Okay? All right, I'm going to hold on just a second. Any questions coming in?
They just want to, Brooke wanted to ask if their final exam is proctored.
Yes, it does. It has to be proctored. And let me tell you, for everybody, I will send an email out, but you all need to find a proctor. That was on the syllabus from day 1. If anybody is close or if anybody wants to come to Farmville, either myself or Danielle or somebody will proctor it here. But if you live in Kalamazoo, Michigan, it'd probably be to your best to find somebody to proctor it for you. You need to have it proctored. It cannot be a family or friend. It needs to be a library or junior college or some reputable place that I approve. I need to know when you're going to take it, and I need their email and their phone number so I can communicate with them. The final exam will have a password on it, so you're not going to be able to log in, and each one has a separate password based on whomever you are, because everybody will be taking it at a different time, or they probably will be taking it at a different time. Whenever you're ready to take it, I had one person yesterday ask me, could they take it April the 28th? I don't remember, but I said absolutely. All I need to know is who's proctoring it and that kind of information. So you do need a proctor. You need to find a proctor. You need to let me know who it is and give me time, give myself or Danielle time to contact them to make sure that they're willing to do it and that they understand what the requirements are. And all the requirements are is for them to proctor you to make sure you're not on your cell phone, you're not communicating with somebody else, okay? Anything else you see there?
Don't see anything else.
Okay, well, I am sorry for the errors on this quiz. I do grossly, or I profusely, I guess I should say, apologize for it. I hope that that will not be the case going forward, but I will try to take a look at chapter 12 in the next day or so to make sure